At this point in the course, we are capable of building basic React apps. We learned a lot about some of the most important features that are baked into React, but there's one thing that's really missing or that we haven't had a closer look at until now, and that is how React actually works behind the scenes. Now, I know that to some students, this is not interesting. You might be one of them. And generally, that's of course fine. You are using a library like React so that you don't have to do all the heavy lifting on your own. However, it really helps to understand how something works that you're using to ensure that you are using it correctly. And whilst I of course do teach you common practices and best practices throughout this course, it nonetheless is important for you to know the tool so that you are able to make the right decisions in the apps you're going to build. So even if that's not super interesting to you, I would strongly recommend that you don't skip this module and at least go through the videos at a higher speed if you're really not interested. We'll also dive in some new features which are related to the behind the scenes work, so I would recommend that you at least watch those lectures, though they will of course make more sense if you watched the entire module. So what's in this module then? We'll have a look at how React works behind the scenes. That does not mean that we're going to dive into the source code. It means that I will show you how React works with your components, how it updates those components, how state is related to all of that. We'll understand that React uses something which is called the virtual DOM, and we'll understand how that works and how it affects updates made to the real DOM, which is in the end what drives your website in the browser. And we'll take a closer look at state management, how React does that, and how state updates are managed by React. A lot of important concepts, so let's dive right in. So how does React work? Let's not forget that React is a JavaScript library for building user interfaces. That's what I taught you at the very beginning of this course, and of course it hasn't changed. We also learned and we saw that React is all about components. We use components to build those user interfaces, and React embraces this component concept. It uses components to effectively compose user interfaces, and it uses components to effectively update user interfaces. There's one important note. We also saw this React DOM thing. And in the end, React DOM is your interface to the web. React itself, React.js, does not know the web. It does know nothing about the browser in the end. React knows how to work with components, but it doesn't care whether those components contain HTML elements or if they contain totally fictional elements. That does not matter to React. It's React DOM to which that matters in the end, and which ultimately needs to bring real HTML elements to the screen. But React is just a library that manages components, that manages state, and that manages different component states, and that finds out how components might need to change and which differences you might have from a previous state of a component compared to the current state. And React hands all that information regarding what changed and what should be visible on the screen, no matter what screen that is, off to the interface it's working with. For example, it hands it off to React DOM, because React DOM is then responsible for working with the real DOM, which is part of the browser, and therefore React DOM is responsible for bringing something onto the screen which the user is then able to see. React only cares about components. It cares about props, which is basically data you pass to components to make components configurable and to enable parent-child component communication. React cares about state, which is internal data inside of a component. And React cares about context, which is component-wide data. Now, of course, React has a couple of other features built in as well, but these are the core features. And whenever props, state, or context changes, components that use these concepts are updated by React, and React checks whether this component now wants to draw something new onto the screen, And if that should be the case, React will let React DOM know about that so that React DOM is able to bring that new screen, that new component, that new output to the screen. So therefore, if we have a closer look at that components real DOM communication here, the question of course is how exactly does this work? As I mentioned, React is concerned about components. And what React in the end does is it uses a concept called the virtual DOM. It determines how the component tree, which your app is building in the end, and every component itself, of course, has a subtree, the JSX code returned by that component. It determines how that component tree currently looks like and what it should look like, for example, after a state update. And that information is then handed off to React DOM, which now knows about the differences and which then knows how it should manipulate the real DOM to match that virtual DOM, that virtual snapshot React derived for your component trees. And related to that, there's one important thing to note. Throughout this course, I often said that React would rerun a component function, that it would re-evaluate a component. And indeed, as I mentioned before, whenever state, props, or context of a component changes, that component function is re-executed. That component is re-evaluated by React. But it is worth noting that re-evaluating a component is not the same as re-rendering the DOM. So just because a component function is re-executed by React does not mean that the respective part of the actual real DOM is re-rendered or re-evaluated. Instead, we have to differentiate between our component part, our React part, and the real DOM. Our components, as I just said, are re-evaluated whenever props, state, or context changes. So React then executes that component function again. Now, the real DOM, on the other hand, is only updated in the places where it needs to be changed based on that difference React derived between the previous state of a component and its tree and the current state after the state, prop, or context change. So the real DOM is not changed all the time. It's changed rarely and only when needed. And that's important for performance because making a virtual comparison between the previous state and the current state, that's fairly cheap and easy to do. That happens only in memory. Reaching out to the real DOM that's rendered in the browser is pretty expensive from a performance perspective because working with the real DOM just turns out to be a performance-intensive task. Of course, not a tiny change in one place, but if you do that tiny change in a lot of places all the time, then your page might become slow because you're working with the real DOM too much. And that's why React has this structure of doing virtual comparisons with that virtual DOM and then only passing the changes between your last snapshot and the current snapshot to the real DOM. That's how React works here. It does this virtual DOM diffing, finding out the difference between two snapshots. And to see a real example, it could look like this. Let's say of a given component, our previous evaluation result, so when the component function ran the last time, is this. And now some state changes, and all of a sudden we want to show a new paragraph. So that's our current evaluation result. In this case, React would determine that the difference between both snapshots is this paragraph, and it would report this change to React DOM so that React DOM can update the real DOM and insert this paragraph. React DOM would not re-render the entire DOM. It would not touch this existing h1 or div element. It would only insert the paragraph after the h1 element inside of the div. That's how React works behind the scenes in a nutshell. Now let's see this in action with some real code, and let's play around with that a bit so that we get a feeling for this and so that we can also find out how this all behaves and possibly changes for props and state changes, for context, and for other components being involved, because it is really crucial that you understand this. Attached, you find this very simple application, which in the end currently just has this app component with a div and a h1 tag. So essentially what you just saw on the slide here. And now let's replicate that behavior I showed you on the slide. Let's say for some reason, eventually a paragraph should be added here. Now, how can we eventually add this and not add it right from the start? Well, with a state change, for example. We could have some state which changes such that initially no paragraph is rendered, but then at some point, because a button was clicked or a timer expired or anything else happened, the paragraph is displayed. Now I will work with a button here, and therefore first of all I will import use state, of course, because we need some state, because as I mentioned, React will only rerun this function and re-evaluate what's on the screen if state, props, or context changes. Now, since this is our root component, props and context is a bit harder, and in the end it's also worth noting that of course it all comes down to state changes ultimately. Even context internally will use some state that might change the value which is then distributed through context. And if we think about props being passed from a parent to a child, how could the value passed through props change? Well, ultimately, only if state in a parent changed. It all comes down to state changes in the end if you think about it. So therefore here we're going to work with some state, and I'll name my state here show paragraph and set show paragraph. And initially that is false. My initial state here is false. And then here we use show paragraph as you learned it in the conditional module, in the conditionals module. This is how we can show a element conditionally. Now, if I save this, of course we will not see the paragraph because our state is false, and currently we have no way of changing that state. Now, in the starting project, you find a button component, just so that we have a nicely styled button. So I will add this button component here, import button from /components UI button. Show paragraph is the label we could have on it. And then here we can add the onClick prop on the button and add a function here, toggle paragraph handler, for example. And this function should trigger when the button is clicked. And it should actually toggle the paragraph, let's say. So I'll rename my caption here to toggle paragraph. And in there, I will then set show paragraph, and I will set the state to what show paragraph currently is not, so that we basically inverse it. The short form would be this syntax, where we set the value for show paragraph to the opposite of the old value. But since we depend on the previous state snapshot, I mentioned that we want to use the function form for the state update here. I will come back to why we do that later in this module again, by the way. And therefore, let's use the function form, previous show paragraph, and we'd return the opposite of previous show paragraph, therefore. And this is the cleaner way of changing our state. And now we bind the toggle paragraph handler to the button. So with that, we have the logic to conditionally show the paragraph. Now to center this, I'll quickly go into my styles here and add text align center here in the app selector. Side note, I'm not using CSS modules here, I'm just using regular CSS imports. Okay, with that, let's click toggle paragraph. And you see the paragraph is here, and it's gone, and it's here, and so on. Now that's interesting to know. But let's now analyze what's happening. First of all, I always mentioned that state changes, prop changes, and context changes would result in this component function being executed again. If that's the case, we should be able to add a console log here and say app running and see this whenever we click the button in the end. Well, let's see whether that's the case. I'll save that. Here's my console, and you see initially app running. That is because the page reloaded and that brought this app component to the screen for the first time. So of course this was executed by React. And for that first render cycle, React then found out that it wants a div, a h1 element, and a button, no paragraph, because initially that's not shown. And it checks that to the last output it saved. And since this rendered the component for the first time, there essentially is no previous output, there is no previous snapshot, and therefore this difference comparison in the end resulted in a div, a h1 tag, and a button to be rendered. And that information was handed off to the React DOM package, which therefore rendered that to the screen. Now if I click toggle paragraph, we see app running again. So that proves my point that for every state change, the entire component in which the state changed is re-executed, is re-evaluated. Now, how is the real DOM affected though? For that, let's go to the Elements tab in the DevTools, and let's expand our div here, the app div. Now, if I reload, we see we just have the H1 and the button element here initially. And now, the good thing about this Elements tab is that things that are changed in the DOM will be flashed. They will be highlighted so that we can see where the real DOM was re-rendered or updated. Now therefore, watch this part on the right here as I click the toggle paragraph button. You see, the only thing that flashed was this paragraph. The H1 and the button element did not flash, neither did anything else. It was just a paragraph. And if I remove it, it's just a div, because from there the paragraph was removed. But the H1 and the button elements were not flashed because they were not re-rendered. And that's what I meant. Only the difference between those virtual snapshots was considered for the updates made to the real DOM. And that is really, really crucial to understand. Now let's see how that might change if we work with more components.